Girls, I am Shamsunisa from Royal Degree College, Chemistry Department. Today we'll start Unit 3rd, Physical Chemistry. In that, we are going to see about chemical kinetics. So today we'll go through chemical kinetics, rate of reaction, variation of concentration with time, rate laws, rate constant or velocity constant K, and the factors influencing reaction rates. First of all, we'll see about chemical kinetics. What is it? It is a branch of physical chemistry that deals with the measurement of rate of reaction and their mechanism proceeding under given conditions of temperature, pressure, and concentration. Rate of reaction. The decrease of concentration of reactant or increase in concentration of the products per unit time is called rate of reaction. Mathematically, it can be expressed as rate of reaction. It is equal to amount of reactant consumed divided by time interval, or rate of reaction equal to amount of products produced by time interval. Rate of reaction, it is equal to minus dC by dt. dC is decrease in concentration of reactant and dt is the small interval of time. Rate of reaction, it is equal to dx by dt. dx is increase in concentration of product. For instance, in the reaction, see here the reaction, A is the reactant which gives product B. If the concentration of A, that is capital A, is initially small and the concentration of the product capital B after certain time is X. So here you can see initial concentration of capital A reactant is small a and initial concentration of the product B is 0. After time t, initial concentration, after time t, concentration of B is X and concentration of A will become A minus X. So a rate of reaction, that is R, it is equal to dx by dt, which is equal to, see here, minus d. In place of x, we are writing what? A minus x divided by dt. So here R, that is the rate of the reaction, it is equal to dx by dt, is always positive quantity. Negative sign indicates decrease in concentration of the reactant with time. Positive sign indicates increase in concentration of the product with time. Now we'll see about variation of concentration with time. During the progress of chemical reaction, the concentration of reactants decreases with reaction time. The concentration of products increases with reaction time. So, rate of reaction can be expressed in terms of reactants or products. For example, for a reaction, see the reaction here. Small a is the molar, small a is the number of moles of capital A, plus small b is the number of moles of capital B. It will give small c is the number of moles of capital C, plus small d is the number of moles of capital D. The rate in terms of reactants and products can be expressed as. How to express the rate? minus 1 by A d concentration of capital A divided by dt. It will be equal to minus 1 by B d, that is the differentiation, concentration of B divided by dt. It will be equal to the products. Listen once again this one very carefully, girls. As we have seen here, the rate income in terms of reactants and products, it can be expressed as, how to express this one? Minus 1 by A d concentration of A divided by dt. What is it? Here negative sign, it is indicating the decrease in concentration of the reactant A. Okay. It will be equal to minus 1 by B d concentration of B divided by dt. Okay. Here also the concentration of the reactant B decreases with the given time. Okay. It will be equal to what? 1 by C d concentration of C divided by dt. Here the concentration of the product C is increasing. So that's why we are not indicating here the negative sign. It means that it is showing the positive value. It will be equal to what? 1 by D, then D molar concentration of D by dt. So this value is also increases. So because of that reason, we are not writing here the negative sign. Here you can see, girls, as we have already told that the concentration of the reactants decreases with reaction time. See here, the concentration of the reactants, they are decreasing with the respective times. Okay. And next is the concentration of the product, it will increase with the reaction time. Here you can see the concentration of the products, those are increasing with the reaction time. Next we'll see about rate laws. Rate law describes functional dependence of reaction rate upon concentration of various reactants. According to law of mass action, rate of chemical reaction varies directly as active concentration of reactants. For a reaction, you can see this reaction here, A plus B. These are the reactants. When they will react, we are getting the product. Then rate equation can be written as, how to write the rate equation for the above reaction? R is the rate of a reaction, that will be equal to dx by dt. It is equal to K, that is the constant, rate constant, it is known as concentration of reactant A and concentration of reactant B. Next we'll see about rate constant or velocity constant K. It is indicated with K. Rate constant is defined as rate of reaction when concentrations of reactants are unity. That is, concentration of A, it is equal to concentration of B, that will be equal to 1. We know R, it is equal, so R, that is the rate of a reaction, it is equal to K, concentration of A, concentration of B. Okay, but concentration of A, it is equal to concentration of B, that one will be equal to 1. That is equal to unity. Okay, both are equal. So R will be equal to then K. Rate constant is also known as specific reaction rate. Now we'll see about the factors influencing reaction rates. What are the factors which are influencing the rate of a reaction? 6 factors are there. First one is effect of concentration of reactant. Second one is effect of temperature, effect of pressure, effect of reaction medium, effect of radiation, and effect of catalyst on reaction rates. First factor we'll see, that is effect of concentration of reactant. Greater the concentration of the reactants, greater will be the intermolecular collision, hence greater will be the rate of reaction. The law of mass action relates the rate of reaction and the concentration of the reactants. This was given by two scientists, Goldberg and Veitch. This law states that the rate of chemical reaction is directly proportional to the concentration of reacting species raised to the power of their coefficients in the chemical equation. Here you can see the reaction. X is the number of moles of capital A plus Y is the number of moles of capital B. When A and B reactants will react with one another, we are getting the products. So rate of this above reaction will be like this. Rate of a reaction is directly proportional to molar concentration of A to the power X into molar concentration of B to the power Y. So when the proportionality is converted into equality, we are writing the constant K. So R it is equal to K, molar concentration of A to the power X, molar concentration of B to the power Y. Now another factor which is affecting the rate of a reaction is effect of temperature. The rate of a reaction increases with increasing temperature due to increase in effective collisions of reacting species or reacting molecules. In general, for every 10 degrees centigrade raise in temperature, the rate of reaction increases by 2 to 3 folds. So the ratio of rate constant Kt plus 10 degrees centigrade divided by Kt, it is equal to or approximately its value is equal to 2 or 3. The ratio is called the temperature coefficient of the rate constant. Now the third factor which is affecting the rate of a reaction is effect of pressure. When the reactants are in gaseous state, the rate of reaction is proportional to the partial pressure of reactants. So you can see here the reaction. Small a is the number of moles of capital A which is in the form of gas reacting with small b is the number of moles of capital B which is in the form of gas, and as a result of that we are getting the products. So rate of this particular above reaction is rate, it is equal to R. It will be equal to K P degree A. What is P degree A? P degree is the partial pressure of reactant A into P degree B, that is the partial pressure of reactant B. K is nothing but the constant, rate constant. Next, fourth factor which is affecting the rate of a reaction is effect of reaction medium. The rate of chemical reaction depends on the medium in which the reaction occurs. Medium affects the reaction rate. By the way, energy is transferred to and from the reacting molecules and by modifying their potential energy. In ionic reactions, rate of reaction is inversely proportional to the dielectric constant of the solvent. Here you can see rate, it is inversely proportional to epsilon. It is nothing but dielectric constant. When the rate of the reaction increases, dielectric constant of the solvent decreases. When rate of the reaction decreases, dielectric constant of the solvent increases. Next factor which is affecting the rate of a reaction is effect of radiation. Rate of reaction increases by absorption of certain radiations. Such reactions are known as photochemical reaction. Means the photochemical reaction, photo means light. In the presence of light, the chemical reaction will take place. Rate of reaction depends to some extent on the intensity of the light absorbed. For example, photosynthesis reaction. 6 moles of carbon dioxide which is in the form of gas reacting with 6 moles of water, the reaction will take place in the presence of light, that is H mu. In the chlorophyll, we are getting the product C6H12O6 glucose plus 6 moles of oxygen. Sixth factor which is affecting the rate of a reaction is effect of catalyst on reaction rate. Generally, catalyst increases the rate of reaction at a given temperature. Catalyst is specific in its action. That is, it may affect the rate of one particular reaction only. It acts by decreasing the activation energy required for the reactants. Here you can see the example. Manganese dioxide can catalyze only the decomposition of potassium chlorate to give oxygen. See here we are seeing this particular graph. On x-axis we are taking reaction coordinate and on the y-axis potential energy. See, when the reactants are reacting in the absence of catalyst, this graph upper side you can see the curve. Reaction path without catalyst, it will take time to get the product. Okay, so here energy of activation without catalyst is more. But if we are using the catalyst, means if we are introducing the catalyst in the reactant, reaction path with the catalyst will be less, isn't it? So energy of activation with the catalyst is less. So within a short time we will get the product. Thank you for listening my lecture.